Hello, everyone. Thank you for joining us for today's web seminar session on inline signing in Bind 9.9. My name is Larissa Shapiro, and I'm the product manager here at Internet Systems Consortium. And we're going to talk about inline signing in Bind 9.9 today. Joining me today is my colleague, Michael Graff, and he's the Bind 9 engineering manager. And you can see our emails and Twitter feeds here if you'd like to get in touch with either of us personally, and we'll also go over some other ways that you can stay in touch with ISC later in the hour. So just a quick overview of the agenda. We are at the top here in Introductions and Logistics, obviously, and then I'll go over a very brief overview of Internet Systems Consortium, who we are and what we do. And then Michael is going to walk us through an overview and tutorial on Bind 9.9 major new feature, inline signing. And the goal here is that you should be able to walk away from this session with a pretty good idea of how to get going with inline signing. And we'll take your questions. We'll actually take your questions at several points during the hour. Everybody's muted right now, but please feel free to ask any questions using the question and answer panel on the right-hand side of your screen. If you want to, you can also click the little hand icon, and someone will call on you that way. And Michael will pause, I think, 3 times during his presentation, and I'll also take questions at the end of the hour. We can take questions on any material from the webinar or really any other ISC-related or DNSSEC-related questions that you have. We archive this presentation and all of our web seminar presentations, and all of the archives and the slides themselves are available on our website at the URL there, and the ones from this session will be available in about 3 business days. So just really briefly, some background about ISC for those of you who may not know. ISC is a nonprofit public benefit organization that does software, services, and operations for core internet infrastructure. And we are very dedicated to open source and to empowerment of the global internet community through what we do. What we do is we make software. Specifically, we make Bind, which is the name server software that's on about 80% of the name servers in the world. The currently deployed product is Bind 9 that we're talking about today. We are also working on a ground-up re-implementation of the DNS protocol in a project called Bind 10. And then we have our DHCP software. It's also an open source and widely deployed DHCP solution. Currently deployed is DHCP 4, and we're also redeveloping the DHCP protocol in a new version that works with the Bind 10 software. We do other software as well, including a dual stack light implementation called After. That's for sharing IPv4 addresses in an IPv6 backbone network. We have our port control protocol software, and we have software for security and resiliency and also for routing that are part of our 2 new forums, the SRF forum and the open source routing forum. We back up all of our software development with our professional services and our public benefit services. So we do consulting on our products and on internet infrastructure operational issues. We do training on the same. We have software support services, professional 24/7 software support. We do custom software development, so your organization has a specific need within Bind DHCP or a specific new project you need an open source reference implementation for, etc. We do custom software development for these types of needs. We run FRoot, which is one of the 13 root name servers for the DNS. And we run that as a public benefit service on, I think, over 70 locations in the world. We also do corporate nodes for FRoot inside corporate infrastructures. And then we have our SNS service. That's our secondary name server service. We have both a public benefit version of that serves a lot of public benefit organizations' DNS resiliency needs. And then we also have a corporate version of that, SNS-COM. Our domain survey is a survey of the IPv4 namespace, and we have both a free and a for-fee version of that survey. And it currently is IPv4 only. That may change in the future. Another major part of our public benefit work is our hosting program. We host a lot of open source projects and other public benefit projects. And then we participate in quite a few organizations, standards driving organizations, public policy organizations, security organizations, operational organizations, and research organizations. That is an essential part of who ISC is and what we do. So that's a really brief overview of what we do. If you have any questions, please don't hesitate either during this hour or later. We love to talk about it. So I would like to get us into the main point of today's session and turn things over to Michael, who's going to talk to us about inline signing.
Hello, everybody. As Larissa mentioned, my name is Michael Graff, and I am the Bind9 Engineering Manager here at ISC. And don't let the management title scare you. I'm still a very technical engineer, and so I can answer questions on pretty much anything DNSSEC related, having been there from day one, and I can also, of course, answer any questions about DNS in general. So today, I'm here to talk about inline signing. So what exactly is inline signing? Well, it is, sorry, my mouse is double-clicking today again. It is a Bind99 server configured in a special way such that it reads unsigned data and then signs it internally automatically. Now, 9.8 and some other versions did do signing, but you still had to feed it signed data to start with, or it could sign the entire zone for you, but then the zone had to be dynamic. With inline signing, that dynamic restriction is removed. So the data source can actually be another server, so we can zone transfer from another server to get the data in, or it can be a disk file. So from a large point of view, this doesn't look any different than a normal server, except that now your zone is automatically signed. A lot of people are very used to using, transferring things from one server to another using zone transfers, or to edit a file on disk and having your zone update whenever you run the RNDC command. And now you can do that without having to do an additional step to sign it. This is probably usable by pretty much everybody from the start, and we think its primary goal is to simplify DNSSEC deployment by eliminating the need for extra tools or extra steps, or really any extra configuration outside of a very simple set of commands. It does not, however, maintain the keys for you any more than Bind9.8 did. This is a problem we are going to be addressing in 2012, but it's not something that right now we have a solution for. So the main benefits are to people who are deploying DNSSEC or have deployed and want to simplify their configuration. It's also good for people who really have an infrastructure in place that they are hesitant or it's very difficult or possibly impossible to change, such as a database-driven IPAM or other data source of your zone data, that you don't really want to change the way this behaves, but you want to sign your zone. You want to minimize cost and also minimize operational changes. Those are two very closely related steps, of course. Operational changes almost always have some form of cost. And sometimes the cost is not just money. Sometimes it's in terms of extra manpower necessary initially, or it's in risk. And DNSSEC is a risky business as it is because it's not as well understood as regular DNS. So we want to minimize that as much as possible. And inline signing also makes it very easy to implement a parallel production and test bed and possibly do something I'm calling selective exposure. When large TLDs first start signing, they don't just sign the zone and publish it. They do a lot of tests ahead of time. And one of those things that they do typically is to have a test bed where knowledgeable clients are querying the signed zone data, but meanwhile their production servers continue serving the unsigned data. And then they can switch people back and forth pretty much at will. And this is a good step to be in for your own experiments, especially if your zone is something that's very, very important. And of course, you wouldn't be here if your zones weren't important. So I went over the sort of quick diagram here very quickly in words. I'm going to go over it in pictures next, but if there are any questions, please feel free to type them in the Q&A section. And meanwhile, I wanted to point out that we do have a knowledge base, and that is a good place to go when you do have questions about Bind. Right now, there isn't anything up there about inline signing, but I'm hoping that there will be very shortly. Okay, so the most common configuration that we have a use case for inline signing is what I'm referring to as a hidden master. And this is pretty popular. Most organizations that do large-scale DNS production have a hidden master configuration. And I'll go through a little bit more about what I mean by that exactly. It is where the master server receives updates in some way, either dynamic updates or transfers it in from some other source, and notifies the slave servers down chain about those changes. The slaves transfer from the master using normal transfer protocols such as AXFR for full zone transfer and IXFR for an incremental zone transfer. And the master itself is not being queried by external resolvers. And that part's important in the inline signing step, but it can be worked around as well. So looking at this graphically, we have our hidden master, our slaves, and they transfer via a very standard transfer protocol. This is pure DNS right now. And clients query the slaves and receive the unsigned responses. And in this case, the hidden master, I don't specify where it gets its data from. It could be fetching it from another server, another thing that looks like a DNS server. It could be another DNS server. It could be a flat file. Whatever it is, it's really irrelevant largely. Now, to bring inline signing in this, and this is the inline signing slave model, and I'll go over some other models a little bit later. The hidden master moves out of the way, and it doesn't have to change other than the inline signer is now its only client. So the inline signer, from the slave's point of view, is the distribution master. The hidden master still does what it does, and the inline signer just sits between them. So when there is an update to the zone, the inline signer signs it, publishes the signed data, and you start serving signed responses without having to change the hidden master where it gets its data from, other than to give some alternate permissions perhaps, and maybe add an also notify clause if it's bind. Now, it's also possible that the inline signer could just replace the hidden master in some situations. If, for example, you largely edit your zone files by hand, or you have something that generates flat text files, and you're willing to take the step forward and just do this all at once, you could just change the hidden master out with a 99 by 99 version and configure inline signing, and it will just work. This isn't something I recommend for the faint of heart. You definitely want to have some operational experience with DNSSEC before you start doing this sort of thing, at least for important zones. If you have a test zone, this might be something worth trying. Now, are there any questions about that? I know I went over it very quickly, but I'm going to spend a little bit more time on the actual configuration side of it. And I do want to mention that if you are not using a hidden master, inline signing can still help. You're doing something completely unusual that we hadn't thought of, well, we would certainly love to hear about that. And we do have support and consulting available for DNSSEC, DNS, and any number of other things. A question. One question I have here is, can the hidden master and inline signer run on the same server? The answer is yes. You could either make replace the hidden master, or you could run a separate instance of bind. Different IP addresses, still port 53. And the next question is the inline signer another server in the middle of the hidden master transfer transaction? I think what I'm being asked, I'm not really certain exactly what that means, but I think what that means is the inline signer sitting between, it sits between the slaves and the existing hidden master. So it is another server or another instance of bind that does that signing transactions. And another question is, I'm assuming this works even if your master is visible. Yes, it does, but you'd have to change what the master looks like for the externally. If your unsigned master, the one I'm still calling hidden master in the picture, is visible, you really have to make that instead be your inline signer that's visible. The inline signer is a fully featured by 9 server and can answer queries just like a slave could in that case. Another question. We're getting really good questions this session. The inline signer is another process like bind. It's actually included within the named process itself, so you don't have to run anything different. It's just standard named configuration. Can the inline signer transfer and sign some zones from other DNS software? Absolutely. The example here is from a Microsoft DNS server. Absolutely, we can. And I'll go into more detail about how to set up the slave side of that as well. The questions are actually scrolling by fairly quickly. Is signer a slave to hidden master and master to slave? Effectively, yes. This is a configuration that a lot of people don't really know initially, and that is that a slave server acts as a slave and it transfers data from another source. But really, the type of server is really just a source selection. If you're a master, you read it from a file. If you're a slave, you get it from transfer. But you can still transfer that out just like another master. So the inline signer just looks like it's a split personality, where the slave side of that transfer either loads from disk or loads from another server. It then does an internal transaction to update the signed copy and then signs it and publishes it on the other end. And the last question I'm going to take during this particular pause is, does the inline signer support multi-master? Well, multi-master is one of those loaded words. And I'm going to kind of gloss over what multi-master could mean here and go with a simpler solution. And that is, you could use multiple inline signers. As long as they're using the same keys and the slaves transfer from only one of them, you can actually sign with multiple machines. So if you need to do fan out or you need to have resiliency or redundancy, it is possible to do this. And signatures are no less valid even if they're generated at different times. As long as the signatures that a server gets are consistent at that exact point in time, it doesn't matter if one server would give out a slightly different answer than another in terms of signatures. Okay, I'm going to move on. So some basic configuration on how to actually set this stuff up. And once again, I mentioned there are two primary models that we're focusing on. One is the slave model, one is the file model. And really, slave model is what the old type slave was. File model is really type master. The three main options that you want to look into are the inline signing yes and auto DNSSEC maintain, and then optionally the key directory specified here. I'm using keys. And the reason you want that one sometimes is that it actually keeps your keys separate from your zones and doesn't clutter up your zone directory as much. Inline signing, yes, is pretty obvious. It turns on this functionality. Auto DNSSEC maintain ensures that once the zone is actually signed, it will refresh the signatures periodically automatically. Now, inline signing without that feature really doesn't make a whole lot of sense to us. So we're probably going to make it so that auto DNSSEC maintain is the default in the future for inline signing yes zones. But right now, you have to specify both. If you go ahead and specify both, you're future-proof. It's not going to affect it's not going to affect the server in the future. But then if you didn't want it to maintain for some reason, you may have to actually specify it to not maintain explicitly. But I really can't imagine anybody actually wanting to do that. As soon as I say that, though, of course, I'll get 10 emails explaining why it's a bad idea, and they actually want to turn that off. But now, inline signing does enable ISC from differences. And what ISC from differences does is it's a feature that minimizes zone transfers down to just the records that have changed. So if you have 1,000 records in a file and you've added one host and an A record for it, what ISC from differences will do is it will read that file, compare it to what you previously had, and then find just the changes that have occurred in the new copy. And for signing purposes, this is incredibly important, which is why it's turned on by default. Actually, I don't even believe you can turn this off for inline signing. It then finds that minimum set of changes necessary. So whenever it passes it over the internal barrier into the signed copy, it knows exactly what it has to sign and exactly what records have changed. Otherwise, it would have to re-sign the entire zone every time, and that's certainly not a cheap operation. So for the slave model, and this is a case where named is transferring a zone from another DNS server, or something that looks like a DNS server. Some people have implemented databases that will actually look like DNS servers enough that a master server can transfer from it. This would work just fine there. Now, as I mentioned before, this server doesn't have to be bind. It can be Microsoft DNS, it can be Cisco, it can be any number of other products. It's standard DNS zone transfer semantics here. But of course, we have a bias. If it were bind, we'd be, really happy. The previous configuration for something that transfers from this host would look like this. You have zoneexample.net, type slave, list the master's IP address, and give it a file to store in. And you may have other options in here too, such as TSIG keys. I highly recommend the use of TSIG keys to secure your transfers, even with DNSSEC. But I'm simplifying it down to just the bare minimum here for what you need to actually transfer the zone in. To add inline signing, it's just add these first two or possibly all three items. Inline signing, yes, auto DNSSEC maintain, and specify key directory if you haven't specified it elsewhere. Now the file model is another one that a lot of us are familiar with. My personal IPAM is pretty much Emacs, which is a text editor. I fully believe that I don't need anything complicated, so I have something that's very simple that I use every time I need to make a change, and I understand it, and it works, and I'm very happy. But I also like my comments, and one of the things that 9.8 servers and before caused me to have to do for bind to maintain it is I had to do dynamic updates, and I really didn't have comments in my zone files any longer, and I did miss those. In 9.9, I can keep my file exactly as I want it to, and named will load that, do the minimum changes, and then sign your zone. So anything that causes the direct editing of the zone file works, or having something that generates a zone file periodically and then reloads it into the server will work just like it does with a normal unsigned server right now. And once again, this is a typical master configuration. Type master, specify the file to get the data from. You just add these lines again, and that causes inline signing to occur. Now, nothing is quite as simple as that, of course. You still have to generate the keys, and I did mention that key generation and key maintenance are something that bind is still not doing for you. You still have to manually configure these. Now, these are some examples on how you could generate keys for testing purposes, but you probably want to check the other options of DNSSEC key gen, because chances are you want to specify the key type, key length perhaps, and other characteristics of the key whenever you generate it. This particular statement will generate keys that never expire, which is probably good for testing, at least initially. But in production, you want to very carefully consider your key management strategy, rolling, and so on, which really brings up the key management topic. And this is a big topic. This could be a webinar all in and of itself, and probably 2 or 3. But you'll find a lot of information about how to manage keys with bind, both on our knowledge base and other places on the net. So I'm not going to go into great details about the intricacies of key management, but I do want to go over some things that I've noticed people doing in the wild that I find a little strange maybe, or I look at things slightly differently than some other people have. And one of those is for key generation and storage. If you have to use an HSM, which is a hardware security module, and you probably know if you do need to use one, go ahead and use it. If you need to use it, great. If you don't need to use it, though, really carefully consider if you really need one, because a hardware security module adds a lot of cost, a lot of overhead, a lot of operational overhead, and you don't typically just want one, you want 2, because if you're dependent upon the single point of failure HSM, you probably need 2 of them. And you have to be very careful with how you make certain keys are backed up properly out of these devices. So one possibility is if you do have to use an HSM, you can always split functionality. You can store the more critical KSK files, which are harder to change, key signing key files on the HSM. and then store the less difficult to change, ones that are completely under your control, except for some timing parameters, on the file system itself, because you can change those much more frequently. And then again, select appropriately sized keys. The interesting thing I find people doing here is they are using 2048-bit keys to protect a 1024-bit SSL certificate effectively. To me, that's a lot like putting a really expensive deadbolt on a screen door. It's just really not that effective. Not to say that 1024-bit RSA is a screen door, but it's less secure than the 2048-bit would be. So, very carefully consider if you really do need your ZSK to be 2048. Perhaps your KSK does because it's longer lived, but your ZSK could be 1024. And one thing to consider here too is that time of exposure, the longer you use the key, the longer it's out there, is not necessarily weakening the key. A lot of DNS people tend to believe that they want to roll their keys far more frequently than they need to. And so about key rolling, my advice here is roll enough that you know how to do it when you need to, but not more often just because the wall clock says to roll. So don't focus so much on the idea that you have to roll every 3 months or every 1 year, but roll whenever there's a reason to. If you believe your security has been compromised, you believe a key has been exposed, if a disgruntled employee left and took a backup copy of the server, certainly, that's an event that would cause a reason to roll the keys. Or if you even suspect that particular situation, that's a good reason to do it. Of course, if your server's been compromised, install a new one and throw out the old one because it's the only way to be sure. But don't worry too much about rolling just because it looks like the wall clock says to do so. RSA has been around for quite some time and is actually pretty secure. So I know this is a lot to digest, and I do see some more questions. What about key management rollovers? I went over that in a little bit of detail. I'm not going to focus too much on that during this talk, primarily because this is a talk more or less about the functionality of inline signing, the reasons to use it, and some use cases rather than actual key management. And I also see, will this webinar be available on the knowledge base? The answer is not exactly as it is, but there will be a link to it. And it will be, I'm going to write up a knowledge base article that more or less goes through the step-by-step instructions that I have in this slide deck, as well as some screen captures to show what you should expect to see. Is inline signing supported for static zones? I'm assuming you mean from a file, as in like master functionality, and the answer is yes. You can, if you have a file that is a flat text file, it doesn't have to be a dynamic zone anymore. It can load it from a flat file and just sign the changes that have occurred every time you do an RNDC reload. And I have 2 more questions. I'm not certain if those are just not cleared out. I believe those are just not cleared out. Okay, I'm going to move on. So another part of this talk is about reducing your risk. And DNSSEC is, as we all know, it's not quite as understood operationally as standard DNS is. Standard DNS, we've all been doing this for several years, and we probably understand pretty well how DNS works. But DNSSEC is new. We don't have a lot of experience about it. We don't know how different devices are going to react. We don't know how different clients are going to react. And we certainly can't predict what customers have as firewalls. From our own operational experience with our secure name server, SNS platform, we have found any number of people who think that 512-byte packets are the only DNS packets that exist in the world because some drafts said that was the limit, and that was 25 years ago, and they haven't kept up with the standards. So whenever one of our customers started signing their zones, we actually got any number of issues there. One was complaints from people saying that we were flooding them with packets, which we were not, of course. We were just giving them bigger packets, and their intrusion detection system was misguided. And also Some people couldn't resolve names any longer because the queries for certain zones got bigger, and they rejected them at the firewall level because once again, their firewall decided that 512-byte packets were the only packets to get through on port 53. And even worse, we find some firewalls that modify the packet in such a way that DNSSEC doesn't work. And you're not going to find these until you actually start deploying within your own environment. Now, granted, a lot of people have already gone that path. The root name servers have actually cleared the way. When people couldn't validate the root or couldn't load up the root, a lot of people fixed this problem pretty fast. But DNSSEC is still scary. When your parent zone doesn't have your DNSSEC information, so there's no linkage between the parent and your zone other than NS records, you're free to do whatever you want with DNSSEC. You can change the algorithm type, you can change the signatures, you can unsign, you can go back to signing, you can do anything you want. But as soon as you pass off your DS records for your key signing keys up into your parent and they put them in their zone and sign them, you can no longer choose not to serve DNSSEC records, not without having them remove it and then waiting some significant amount of time for those records to expire out of caches. So in many ways, DNSSEC is kind of scary because once you make that choice, you're stuck with that choice. It's not quite as bad as just publishing a bad NS record, for example. You really are stuck with DNSSEC once you go past a certain point. And you need to find a safe approach and what you feel comfortable with. And every situation is unique. And we are here to help. So if you have any questions, concerns, contact our sales department. Go on to Bind Users, which is a sort of a community help list, and ask other people what you think you should be doing. Everybody has a unique situation. Everybody has one or two quirks that make them different than everybody else out there. So we're here to help. Now, along the idea of risk lessening, parallel deployment is the procedure that I recommend for the most part. Now, this reduces risk by reducing changes to existing infrastructure. It does add infrastructure. It adds new servers or new virtual hosts or new instances running on servers, whatever level you're willing to able to feel comfortable with. But it does give you a chance by adding servers to upgrade the ones that you have too. And as we probably all know with DNSSEC, the data is larger and the CPU time is more extensive. So it's not just a simple load that 10 megabyte file into RAM and serve it. It's more like load that 70 megabyte file into RAM. So in some cases, machines that otherwise could handle unsigned zone data with no problem whatsoever are suddenly going to start serving some rather large databases. They're also going to be providing more bits on the wire, so they may speed up the Ethernet cards. Any number of things might need to change. And with the parallel deployment, you are able to switch back and forth mostly. Once again, as soon as you publish your keys to your parent, you're stuck. You really don't want to start changing back and forth at that point. But you can do that at will before you publish the keys to the parent, before the parent loads your keys and provides that linkage. And the primary reason I like the parallel deployment is it allows you to get your feet wet without really a whole lot of risk. You can have a test bed, which is where you'd have maybe your internal resolvers validating. You can also selectively expose people to the newer, larger responses. So you can decide that San Francisco, for example, will get DNSSEC records provided to them, but nobody else will. And you can control this with firewalls, various types of load balancing configurations, locality, that sort of thing. Whatever you would normally do to load balance your servers across the world, you can use that to selectively expose certain areas, and you can switch them back and forth. If you have a DNS server serving DNSSEC data in one site and one right next to it that doesn't, you can decide to switch all traffic around in whatever method you wish. And graphically looking at this, this is the most simplified version I could come up with, where the hidden master is unchanged, except it also notifies and allows transfer from an inline signer. But the existing slaves haven't changed. The inline signer publishes to a brand new set of slaves, and you can control who gets queried from which server base. So I'm hoping you're all thinking, wow, when can I get this cool thing? Well, you can get the release candidate number 1 today, but the final release is scheduled for February. I believe we've nailed it down as February 7. And when we do release that, as customers, if you're a customer, you'll get a notification, but also we'll send out our notifications to bind announce list. So if you're interested in this particular feature, and I assume everybody is because they're here right now, then you want to subscribe to that list if you're not already on it. It's a low bandwidth list. It's not used for a whole lot of marketing purposes other than to announce webinars and such, and feature releases of bind. So if you want to keep track of what versions of bind are out there, this is the list to be on. And I'll take more questions at the end if there are any, so please keep them coming. I don't see any right now, so I'm going to go ahead and pass it back to Larissa, who will continue talking about what type of training we offer.
Thanks, Michael. So as I mentioned earlier in the session, we do support all of our software with our services, which includes our training, and I just wanted to let you guys know about the different kinds of bind and DNSSEC related training that we have so that you can look into it if it makes sense for you. Basically, we have 3 classes that relate to bind. There's a 2-day introductory bind course, which covers all your basic operational needs around bind, but is not a DNSSEC course. Then we have a 5-day introductory and advanced DNS and bind course, which has the introductory part, that's the 2-day class, but then it has a further advanced session, which includes DNSSEC and also some other more advanced bind-related topics. We do also have a 3-day DNSSEC implementation and deployment workshop. That's a specifically DNSSEC-focused course, and that goes into a lot of detail. There is also a 3-day IPv6 fundamentals workshop, which will cover some DNS topics as well as other networking, DHCP and other networking topics, anything related to IPv6. And then we also have a DHCP course, and sometimes we do have other trainings that relate to other software and services that we do. As you can see from this list, which is the first half of 2012's training offerings, we do them all over the world. And we can do them in locations that are not on this list. If you're interested in having training either inside your organization or just you're in some specific part of the world where we don't have one and you'd like to see one there, please don't hesitate to get in touch either with your own account manager, or you could drop an email to sales@isc.org, and someone from training would get in touch with you, and if we can offer something in your region, we will. So, and I see there's questions about training. I'm going to take questions at the end of this section, and actually we'll take, that'll be the last question period. So any questions you have about services, training, back to inline signing, anything else ISC does, please don't hesitate. So we also have more web seminars coming up. We're doing them at least once a month at this point, so we'll have them all year. The next one is in a couple weeks, and if you aren't tired of hearing my voice, you'll be hearing more of it, because I'm going to do a product update for actually basically any upcoming ISC things that are new and exciting for 2012, what they are, what we might be doing this year. And if you have things you'd like to hear about, please let me know. This seminar is specifically a benefit for members and customers. If you are already a member or customer, you can get in touch with your account manager and sign up for the session. If you are looking into becoming a customer, you could shoot an email to sales@isc.org if you're interested in this session, and we'll see if we can make an arrangement for you. Also, coming up soon, we have the secondary name server offering is doing a web seminar in February on the 8th, and then this is our first time doing one in Spanish. We're doing a secondary name server offering in Spanish on the 22nd of February. And then we have a cybercrime session specifically around passive DNS and DNSRPZ in March. And we have some other topics planned for this year. DNS resiliency training certification, which is to do with our new certification program, which we'll be rolling out, where you can, once you've done one of our trainings, you can take a test, and if you pass, you can be certified as blessed by ISC for your DNS skills. We also are going to have a discussion of our registry services, and we're going to be having more sort of informal chats with engineers, either development engineers or operational engineers on different topics. And the first one that has been asked for is an ops chat about Anycast, and I think specifically about how we use Anycast inside our F-Root installation. So if you have other topics you're interested in here, please don't hesitate. We're happy to schedule seminars on any topic of interest in the community. And you can sign up for any of these sessions that are already scheduled, or view archives of the old ones, or see what's coming next at isc.org/webinars. And we have a special offer for attendees of today's sessions, and we pretty much always do one of these, and this one's been popular. What it is 20% off of your choice. You can do a 5-day bind with DNSSEC training, or the 3-day DNSSEC specific training, or you can do something that Michael referred to earlier, which is a bind configuration review for DNSSEC, and that's a consulting engagement. There's more information about the consulting engagement at the URL that's on that page there. Basically, you need to sign up within the next month to take advantage of this, but you can use it for any training through the end of June, so for the next 6 months. And we'll be sending out an email following the session with a coupon code that you can use so that when you register on the website, you can get your discount. And I just want to go over really briefly how you can stay in touch with ISC. We have social media for Facebook, LinkedIn, Twitter, and you can find all sorts of things come across there: articles, release announcements, security advisories, job postings, and blog articles. We also will put up knowledge base articles if they seem of particular interest. We try to keep it from being noise, make sure it's actually a signal. And ISC Resources, this is more technical resources than the social media stuff is, although the social media stuff can be quite technical. Michael already mentioned the knowledge base. This is a relatively new resource. It's an extensive and growing database of articles and resources on technical topics around ISC software and services. And then the bind announce list Michael already described for you, but that's really strongly encouraged for anyone who's using bind. That, among other things, that's the first place you're going to hear about it if we have an important thing like a security release, if you're a member of the community, and also for just general announcements. And then bind users is a really great resource, a free community resource of people who probably have similar needs to yours. So check those things out. And I'm going to take questions now. I had one question about training on the West Coast. There is training on the West Coast, actually, and I think possibly the website, the slide was out of date, but there's training in Redwood City in March, introductory and advanced bind topics. So if you look at isc.org and you go to the training section, you'll get the most up-to-date slide, and I apologize if that wasn't the most up-to-date listing there. So I'm just going to pause for a second and see if there's any other questions coming. It seems like a lot of the DNSSEC specific questions were already asked. Hang on a sec here. Yeah, I think that all the questions have been answered. So in that case, I'm just going to say thank you very much to everyone for your time. And also one last note is that there's one more session of this webinar if you have colleagues who would be interested. It's at 7 p.m. tonight Pacific time, which is, I know, very late for East Coast of the United States and Europe, but it's tomorrow morning for Asia. So if you have Asian colleagues who would be interested, or West Coast of the United States colleagues who would be interested, let them know. Thanks so much, everyone. Have a great day.
Thanks for coming.